In this video, I will take you through the steps you need to follow to balance redox reactions in acidic medium without challenges. In the first step, write down the unbalanced equation. In step 2, determine the oxidation numbers of the elements in the equation and use the numbers to establish which elements are being oxidized or reduced. Step 3, split the reaction into half reactions. That is, separate the reaction into oxidation and reduction half reactions. Step 4, balance elements other than oxygen and hydrogen. Ensure all non-oxygen and non-hydrogen atoms are balanced in each half reaction. Now, balance oxygen using water molecules. That is, add water molecules to the side that needs oxygen. In step 6, balance hydrogen using hydrogen ions. That is, add hydrogen ions to the side needing hydrogen to balance the number of hydrogen atoms. Step 7, balance charges using electrons. Add electrons to each side of the half reactions to balance the charges. Step 8, equalize electrons in both half reactions. Multiply the half reactions by appropriate factors to ensure the number of electrons lost in oxidation equals the number gained in reduction. In step 9, add the half reactions. That is, combine the two balanced half reactions, canceling out electrons and any species that appear on both sides. In the final step, verify the final equation, ensuring all atoms and charges are balanced. These steps seem many and worrisome, but as you start to use them, you will see how things fall in place naturally. I will now take you through few examples. Take note that it is very important to know the redox rules in my previous videos. So, if you have not watched them, I will advise you to do so. Example 1. Balance the following reaction in acidic medium. Step 1. Write the unbalanced equation and identify the reactants and products. Step 2. Determine the oxidation numbers of the elements in the equation and use the changes in the oxidation numbers to determine which elements are oxidized or reduced. If you are not sure on yourself here, you should watch my earlier video in part 1. Step 3. Split the reaction into half reactions. That is, separate the reaction into oxidation and reduction half reactions. Permanganate ion is reduced to manganese 2 ion, and iron 2 ion is oxidized to iron 3 ion. Step 4. Balance elements other than oxygen and hydrogen. In the oxidation reaction, iron is balanced. In the reduction reaction, manganese is balanced. Step 5. Balance oxygen using water molecules. Step 6. Balance hydrogen by using hydrogen ions. This gives us a permanganate ion plus 4 hydrogen ions, yielding manganese 2 ion plus 4 molecules of water. Step 7. Balance charges in both half reactions with electrons. In the oxidation reaction, we will get iron 2 ion oxidized to iron 3 ion and 1 electron. And in the reduction reaction, we will have a permanganate ion plus 8 hydrogen ions plus 5 electrons, yielding manganese 2 ion plus 4 molecules of water. Step 8. Equalize electrons in both half reactions. Multiply the oxidation equation by 5 to match the number of electrons gained in the reduction reaction. Step 9. Add the half reactions. That is, combine the two half reactions. And after canceling out the 5 electrons from both sides of the equation, we have our final equation as 1 permanganate ion plus 8 hydrogen ions plus 5 iron 2 ions, reacting to yield 1 manganese 2 plus 4 molecules of water, plus 5 iron 3 ions. Let us verify the final equation. Concerning the atoms, there is 1 manganese on both sides of the equation, 5 iron species on both sides. What about oxygen? There are 4 on both sides, and we have 8 hydrogen species on both sides. Charges. On the left side, we have a total of plus 17, and on the right, a total of plus 17. Both atoms and charges are balanced. Example 2. Balance the following reaction. Potassium permanganate plus sodium oxalate plus sulfuric acid reacting to form manganese sulfate plus potassium sulfate plus sodium sulfate plus H2O plus carbon dioxide. We are going to make this one shorter. Step 1. Assign oxidation states and identify redox changes in the species. Manganese in potassium permanganate has oxidation number of plus 7. In manganese sulfate, it has plus 2. This implies it is reduced. Carbon in sodium oxalate has oxidation number of +3. In carbon dioxide, it exhibits oxidation state of +4. Step 2. Write reduction and oxidation half reactions. Step 3. Balance electrons. To balance electrons, multiply the reduction half reaction by 2 and the oxidation 1 by 5. Step 4. Combine the two half reactions. Step 5. Add the spectator ions to get your final balanced equation. Balance the following equation. Potassium permanganate plus oxalic acid plus sulfuric acid undergoing a reaction to form potassium sulfate plus manganese sulfate plus water plus carbon dioxide. I believe in you. Handle it and live your comments. Always ready to answer your questions. Thanks for watching, and don't forget to like, comment, and share.